In this video, we'll talk about how to solve a system of equations using a method known as substitution. So let's work through a few examples. Let's say we have the following equations. 2x plus y is equal to 1, and 3x plus 4y is equal to 14. We want to figure out for what values of x and y make both of these equations true. So usually when we have a system of equations like this, and we see that one of the variables, either x or y, has a coefficient in front of it of 1 or negative 1, that's a dead giveaway that we want to use the method known as substitution. So for example, in this one, we can imagine that this y has a coefficient of 1 right in front of it. So what that means is we can solve for y very easily, and then we can substitute that into this equation to solve for x. So for example, let's consider this first equation. To solve for y, we can just subtract a 2x, or move this 2x over to the right side. So we can get y is equal to 1 minus 2x. So now that we know what y is, we can plug that into this equation right here. So let's do that. We get 3x plus 4 times, so we're going to plug in this for y, 1 minus 2x is equal to 14. Now notice that this whole equation is now only using x's, so we can solve for x. So we can say 3x plus, we can distribute this 4 to both of these terms. So 4 times 1 is 4. 4 times negative 2x, that's negative 8x, is equal to 14. So if we combine our like terms, 3x minus 8x, that's negative 5x, plus 4 is equal to 14. And then if we subtract a 4 from each side, so minus 4, we get negative 5x is equal to 14 minus 4, that's 10. Now to solve for x, we can divide both sides by negative 5. So these negative 5's go away, and we're left with x is equal to 10 divided by negative 5, that's negative 2. So x is negative 2. Now what we can do is we can plug that back into our formula up here for x, and we can solve for y. So we'll say 2 times negative 2 plus y is equal to 1. So 2 times negative 2, that's negative 4. So negative 4 plus y is equal to 1. And now if we add a 4 to each side, these will cancel out and we'll be left with y is equal to 5. So our final answer, we can write it as a coordinate pair, negative 2, comma 5. And if we want to double check that we got the right answer, we can actually plug these values for x and y into these equations and see if they're true. So for example, 2x plus y equals 1. Let's plug in a negative 2 for x and 5 for y and see if this is actually true. So 2 times negative 2 is negative 4 plus 5 is equal to 1. So negative 4 plus 5, that's 1. So 1 equals 1. That checks out. And then if we want to double check our second equation, we can plug in x and y for that. So 3 times negative 2 plus 4 times, we said y was 5, is equal to 14. So let's see if this is true as well. 3 times negative 2, that's negative 6, plus 4 times 5 is 20. So negative 6 plus 20, that is 14, and that does equal 14. So that checks out as well. So our final answer is negative 2, comma 5. All right, let's try another example. Let's say we have negative 5x plus y is equal to negative 2, and negative 3x plus 6y is equal to negative 12. So how can we solve for x and y? Well, once again, since we noticed that one of these variables, this y right here, has a coefficient of either 1 or negative 1, in this case it's a 1, we can use the method of substitution, where we solve for y, and then we substitute that into the second equation. So if we imagine that we add a 5x to each side of the equation of this first equation, we'll get y is equal to negative 2 plus 5x. So we solve for y very easily, and now we can plug this y into this second equation. So let's do that. So we have negative 3x plus 6 times y. We said y is negative 2 plus 5x. And that's all equal to negative 12. So we get negative 3x plus, we can distribute the 6 into each of these terms in the parentheses. So we get 6 times negative 2, that's a negative 12. And then 6 times 5x, that's plus 30x, is equal to negative 12. So if we combine like terms, we have a negative 3x and a positive 30x. Negative 3 plus 30, that's 27x. And then we have a negative 12 right here, so minus 12 is equal to negative 12. Now if we add a 12 to each side, we'll get 27x is equal to negative 12 plus 12, that's 0. So if we divide by 27 to get x all by itself, 0 divided by 27, that's just 0. So x is equal to 0. Now that we know that, we can plug that back into this first equation up here. So we get negative 5 times 0 plus y is equal to negative 2. So negative 5 times 0, that's just 0. So we're left with y is equal to negative 2. And that's our answer. So we can write our final answer as a coordinate pair, 0, negative 2. That is the solution to these two equations. All right, let's try one more example. Let's say we have x plus 3y is equal to 1 and negative 3x minus 3y is equal to negative 15. How can we solve for x and y? Well, once again, notice this x has a coefficient of 1. So that's a dead giveaway that we can just use substitution, where we solve for x and then we substitute that into the second equation. So to solve for x, we just need to subtract a 3y from each side. So we'll get x is equal to 1 minus 3y. So we solve for x very easily. Now we can just substitute this into this second equation. So we'll get negative 3 times x. So we said x is 1 minus 3y. And then we have minus 3y is equal to negative 15. So if we distribute this negative 3 into each of these terms, we get negative 3 times 1 is negative 3. Negative 3 times negative 3y, that's a positive 9y. And then we have minus 3y is equal to negative 15. So we can do 9y minus 3y, that's 6y. So we get negative 3 plus 6y is equal to negative 15. Now to get y all by itself, we can add a 3 to each side. So we get 6y is equal to negative 15 plus 3, that's negative 12. And to solve for y, we can divide both sides by 6. So y is equal to negative 12 divided by 6, that's negative 2. So that's our y value. Now we can simply plug that back into this first equation up here. So we get x plus 3 times y. Y we just found was negative 2 is equal to 1. So we get x plus 3 times negative 2, that's negative 6. So let's write x minus 6 is equal to 1. And to solve for x, we can add a 6 to each side. So we get x is equal to 1 plus 6 is 7. So x is equal to 7. So we can write our final answer as a coordinate pair, and we can say 7, negative 2. That is our final answer.